Hello all, welcome to the series of operating system. In this video, we are focusing on a round robin CPU scheduling algorithm. So this algorithm is very important because it focuses on some time. So that is why the criteria of a round robin algorithm is a time quantum. That means for some time the process will be executed and then it will be swapped from CPU state to the ready state. Okay, and the mode is a preemption, or you can say the preemptive. Preemptive, that means for some time only the process will be executed and again it will be loaded into the ready state, and then from ready state to CPU state as per the burst time. Okay, so here in this example, let us consider I have some processes in the ready queue. Okay, and as we know, whenever we load process in the ready queue, that means in the RAM, so we send process into the running state. Okay, so that means, for example, one process is there which will be executed for some time. It could be 1 unit, it could be 2 unit, 3 unit, or whatever time is given. So according to that, the process could be run in the running state, and after that time completion, so the same process will be preempted in the ready queue. So that is the preemption and time quantum criteria and mode for the round robin scheduling algorithm. So based on this we will solve this example. You can see here some four processes are given and we have to calculate their average timing and their turnaround timing. So time quantum is, that means for 2 units we have to execute that given process. What happen if the burst timing is more or less? So we'll see through this algorithm and this example. You can see here arrival timing and burst timing is given, and similar to other algorithms, here we have to maintain the queue. Okay, queue and Gantt chart. But here, additionally, instead of Gantt chart, we are maintaining the ready queue because it will be easy when we use separate ready queue for arrived processes in the ready queue. Okay, and then the Gantt chart also we will use, and it will be helpful again for calculating the example. So that means, as we know, we have to check whether any new process is arrived in the ready state or not at the first unit in the sense 0th unit. So at the 0th unit, only one process is there, that is P1. You can see arrival timing is a 0. Okay, so that means P1 process is arrived in the ready queue. Is there any other process? No, there is no other process. Fine. So that is why P1 process we will execute firstly for 2 unit, because our time quantum is a 2 unit. But see, the burst timing of this process P1 is 5. That means when we execute that process for 2 units, still we have 3 units more, right? That means 5 minus 2 is equal to 3 units. So 3 units are left for the process P1. Now, when we execute P1, at that time we have to again check, is there any new process arrived in the ready queue? Yes. See, P2 process at the first unit, that means here somewhere P2 process is arrived. P3 process at the end of this, that means when P1 process was completed for 2 unit, at that time P3 process is also arrived. That means you can see in the ready state, P2 is also there and P3 is also there. Okay, but what about this P1? Because still 3 units are remaining about the P1 process. So in that case, that P1 process will be again printed in the ready queue. So that is the criteria. That is the criteria for the round robin algorithm. So that means after arriving new process, we have to check whether the current process is having some remaining timing. So that process we need to add into the ready queue. Okay, now P2 process, P3 process, and P1, three processes are there. And now we will execute P2 for how much unit? 2 unit, because our time quantum is a 2 unit. So that is why 2 plus 2, 4. Okay, so that means this process we have executed. Is there any new process arrived while executing P2? You can see, yes, while executing P2 at this last unit, you can see P4 process is arrived. So we will add P4 process into the ready queue. Okay, so after adding P4 process in the ready queue, we have to add a remaining execution timing because P2 process burst timing is a 4 and we have executed for 2 units. That means 2 units are still left. In this case, we will add P2 process again in the ready queue. Fine. Now P3 process, as per the sequence, P3 process we are executing here, and how much timing for 2 units because time quantum is 2. So P3 will be executed for 2 units. So that means 4 plus 2, that is 6. And see, burst timing of the P3 process is a 2. So after executing that process for 2 units, so we will not have any remaining value remaining unit. So that means P3 process is a completely executed. Okay. Now again we have to check while executing P3, is there any new process arrived? There is no new process. So that is why whatever new sequential processes are there in the ready queue, we have to execute those processes. Okay. So that means we will execute P1 again. For how much timing? 2 unit because time quantum is a 2 unit. So that means 6 plus 2, that is 8. See now P1 we have executed firstly for 2 units and now for 2 units, that means from 3 minus 2 again still we have 1 unit for process P1. Okay, is there any new process? No, there is no new process. That is why we are not adding any process into the ready queue. Fine. But see, there is no new ready process, there is no new process in the ready queue. That is why the remaining unit, 1 unit is left for P1. So that is why again we are loading P1 process into the ready queue, and this is the funda here. See, initially here also P1 we have loaded, then after some processes, that means after P2, P3, again we have P1 loaded, and again after P4 and P2 again we have loaded P1. That means this type of preemption can be repeated several times. That is why this new ready queue we have generated. For other algorithm, there is no need to generate ready queue, but for round robin, we have to use a ready queue for recalling all these newly arrived processes as well as already arrived processes. Okay. Now, after executing this P1, we have sequentially P4 process in our ready queue. So that will be executed for 2 unit. So that means 8 plus 2, that will be 10. Now see, what is the unit, what is the burst timing of P4? 1. Okay, still we have executed for 2 units. That means it is wrong because burst timing is only 1 unit. So there is no need to execute that process for 2 units. So that is why we have to execute it for 1 unit only. So 8 plus 1, that is 9. So here you could do some mistake because time quantum is 2 unit, but burst timing is only 1 minute. There is no need to execute for 2 units. So execute it only for 1 unit. So that means P4 process is also completely executed. Now we have only P2 and P1 processes, and in a ready queue sequentially we have P2 process. So execute that P2 process for 2 units. If 2 units are left, yes, 2 units are left. So that is why execute that P2 process for 2 units. So 9 plus 2 will be 11. Okay, and here P2 P2's remaining bus time is also 2. That is why, and our time quantum is also 2. That is why we are executing for 2 units. That means P2 process is also done. Only one process is remaining. There is no new process arrived in the ready queue. Only one is there, that is P1. So P1 will be executed for how much timing? And you can see here initially we executed for 2 minutes, so at that time remaining timing was 3. Then after some time we have executed P1 again for 2 minutes. That means here, firstly here, then secondly here, and now here. So here we have executed for 2, here we have executed for 2. That means for 4 times we have executed, and original was 5, right? That means only 1 unit is left here for process P1. That is why process P1 will be executed for only 1 unit. There is no need to execute for 2 unit because only 1 unit is left. And likewise, we have to uh, uh, calculate the round robin algorithm. You can see completion timing completion. When P1 is completed at last, at the 12th unit, P1 is executed. When P2 is executed, completed at 11th unit. You can see here at this moment, P2 is executed. At this moment, P1 is executed. When P3 is executed in the sense complete execution at the sixth time, right? So 6. When P4 is executed, you can see here P4 is completely executed. So that is completion time, that is 9. Now turnaround timing is a T8, turnaround timing is equal to completion timing minus arrival timing. So completion timing is 12 minus 0, that is again 12. Completion timing is 11 for P2 process and arrival timing is a 1. So 10, 11 minus 1, that is a 10. For P3, completion timing is a 6 and arrival timing is a 2. So 6 minus 4, that is a, 6 minus 2, that is a 4, right? And for last process, completion timing is a 9 minus arrival timing is a 4, that is 5. Waiting timing is nothing but the turnaround timing minus burst time. So turnaround timing is a 12 minus 5, so 7. 10 minus 4, 6. 4 minus 2, 2. 5 minus 1, that is 4. So that is our waiting time. And responding timing is what? When initially CPU is given to the process. So initially for P1 process, at the 0 timing only we have given the CPU. So that timing minus arrival timing. So initial timing is 0, arrival timing is also 0. 0 minus 0 is a 0. Initially when CPU is given to the process, here at the second unit, P2 process is given to the CPU. So that 2 minus arrival timing. 2 minus 1 is 1. And when P3, when CPU is provided to the P3, at this moment you can see 4 is the initial timing for P3 process. That means 4 minus arrival timing 2. 4 minus 2, that is a 2. And at last, when P4 is received to the CPU at initially at the 8th unit. So 8 minus arrival timing is 4. So 8 minus 4, that is a 4. So this is the responsive timing, and obviously average waiting timing and average turnaround timing. So just add these numbers and just take an average. So 10 for TAT, average TAT, 12 plus 10 plus 4 plus 5 is equal to 31 divided by 4. So whatever answer is there, just put your answer in the comment box in the form of unit. Okay, so 7 point something unit will be the average turnaround timing. Similarly, average waiting timing is also same. 7 plus 6 plus 2 plus 4 is equal to uh, 17, 19 divided by 4. Okay, so again some unit will be the answer. Okay, so put your answer in the comment box. So likewise, we have to solve the round robin algorithm. So in the comment box I have given one example for you. Just solve that example and put your answer in the comment box. Okay, so that is about the round robin algorithm. Thank you.